parking comp at the front, so you get free parking. Or if you want to pay for parking, that's up to you. So next we have Paul Gizzo.
Close enough.
Gilzo.
Close enough.
All right.
It's a weird name.
I like it. With the introduction to GitOps. Also a reminder, please make sure your cell phones are off or on silent. And Paul, all yours.
Very good. Good afternoon. I got you right after lunch, so that means everybody's going to be nice and sleepy. So I promise I will do my best not to put you to sleep. With that said, I know the other four panelists, or know of them. I know that session's going to be really good. It was on my list to go see. So if for any reason during my presentation you decide this is not what I thought it was going to be or it's not pertinent to me, that's totally okay. Just give me a little signal. I'll know what you're doing. No hard feelings, because like I said, that's going to be a great one as well. I will warn you before I start that I am not a Kubernetes expert, and Kubernetes is often associated with GitOps. My background is not infrastructure. I have a career in development for the last 20 years with the University of Missouri. So my curiosity about GitOps was born out of being part of the team at that university in trying to modernize and standardize and make our development processes better. So with lots of meetings with the infrastructure team, and ultimately the university ended up going with a platform as a service company that does GitOps, and that's kind of how my curiosity about the topic was born. Because as a developer, I felt that it was really important for me to understand my infrastructure and how it operated. So kind of an overview of what we're going to do today. We're going to go in, we're going to talk about, do a little bit of a history about where we were in, as far as the industry and infrastructure, and how we got to the point where GitOps is a solution that's needed. Then we'll define GitOps, we'll talk about the principles behind GitOps, we'll talk about how GitOps is different from DevOps and how they're also related. We'll talk about the advantages that GitOps brings to your organization. And since many of us at WordCamps are developers, we'll talk specifics about what benefits GitOps brings the developers. And then not so much disadvantages, but just maybe shortcomings or things that GitOps doesn't cover. Now, I do have one overarching goal personally, and that is that every single one of you, when you leave here, leaves with one piece of new information that you didn't have when you started. So if I fail in my personal mission, please come talk to me afterwards. Let me know how I can improve this session for future people. All right, so some of the challenges. Well, in order to thrive, right, we all need to innovate. We're all trying to innovate in our own spaces, whether that's driving revenue growth, digital experiences and features for our products. Higher education might be enrollment and admissions. We're all trying to thrive and trying to innovate. But every time you try to innovate, we have complexity, right? We're all limited in time. We're all limited resources and talent pools, especially now with the labor market so tight. In addition, we have to deploy more frequently, right? We're trying to increase our features and that experience. We're having to deploy more often. And as developers, we're often driving the stack. So like in the WordPress ecosystem, we used to be all in the LAMP stack, right? It was all PHP, MariaDB, and where are we moving now? This is where you can talk back to me. It's okay. Where are we moving now? Like the Jamstack, right? And Node and headless and decoupled, right? We're starting to move into different stacks. So we have the stack diversity, and now you might have, maybe you're deploying to Versailles or Heroku for some of your stuff, and you're over at AWS, you're over at Google. You got all this stack diversity. You might be starting to move out into virtualization, containerization, and orchestration. That's complexity. And I already mentioned kind of the architecture with microservices and decoupled. And somebody somewhere in your organization is saying, hey, whoa, wait, what about security? What about compliance? And it's hard. It is difficult. It's challenging to adapt to all this complexity. It's hard to move fast, right? So if you're struggling trying to manage your stacks, it's going to be hard to deploy to those. If you don't have somebody that's an expert, they might not have them optimized. In addition, we used to have a lot of silos, right? Your infrastructure team used to be completely separate from your development team with different goals. Your infrastructure team's goal is to give you performant, healthy, optimized infrastructure. And that typically means that once you get that figured out, what do you do? That's where you talk to me again. What do you do? What does infrastructure like to do? No, they don't like change, do they? Infrastructure likes to get it right and then leave it, right? And as developers, when we're driving that stack, what do we need? We need the updates, right? We need different stacks. So you end up with these competing goals causing delays and frustrations. In addition, it's hard to scale. When you move into a new stack, especially if you're trying to build that stack yourself, you're going to need somebody with that knowledge expert, right? You're going to need them to know, if you're doing a Jamstack, how to build that Jamstack to scale. All right, and that can lead to outages and downtimes and often the absence of governance. So DevOps to the rescue, right? How many of you are using a DevOps philosophy? Some of you. If you're not familiar with DevOps, it's really just a methodology of thinking about focusing on the client and bringing your teams together. So instead of having a separate infrastructure team and a separate development team, you bring them together and you realign their goals with a heavy focus on shorter, faster iterations of your software. And again, that hyper focus on their needs with that continual feedback loop. So we ended up with a lot more collaboration. We also focused in on a lot of automation. So everything in the software development cycle that we can automate, we do. And we build, we test, deploy. We build, we test, deploy. So we have improved communications, shorter development cycles, reduced deployment failures because we're deploying smaller pieces more frequently, and we use a workflow of some sort where people are approving those so we can catch those errors ahead of time. Faster delivery of features, which means more time to innovate. But for the most part, in those iterations, those initial iterations of DevOps, we didn't include infrastructure. And part of that's because it wasn't there. It wasn't quite ready. How many of you, when you first deployed your WordPress site, was on a physical server? Anybody? Am I that old? Okay, a couple of you. Okay, I was going to feel really old. Like, we used to have just physical servers, and they were expensive. Okay, so you didn't get to have a development server and a staging server and a production server because that's at least 3 servers, right? And then once we figured out, oh, you should actually separate your SQL server from your web server, well, now that's 6 servers. Right? So it's really expensive. It was hard to convince organizations that you really needed that much. So then we saw the rise of virtual machines where we could run virtual servers on top of that physical hardware. And now it was much cheaper to deploy an actual development, staging, and production server. So that was a step forward. The problem, though, is that virtual machines in the beginning still required a sysop to go in, configure them, set them up, install all the software. And sysops aren't developers, right? They might have built some imperative scripts, but it typically was not centrally managed. It wasn't version controlled. And so what could happen is, as from sysop to sysop, as they set things up, you could end up with a lot of drift, right? Your development server wasn't quite the same as production. So you can end up with bugs in production that are fine on development. In fact, has anybody ever had that problem? Okay, at least a couple of you. Yeah, I know I do that all the time. The other thing is there was a very much of a pet mindset with our servers. In other words, we named them, we gave them a house, we fed them, we cared for them. If they got sick, we nursed them back to health. And then eventually, as they got older, and we retired them to a data farm upstate, right? So we just gave them a lot of care. So then we saw the first generation of configuration management software, stuff like Puppet and Chef, which allowed you to install an agent, and then you could create your scripts, and it would run all those scripts for you. It would do all the configuration, all the setup for your machines. The problem was they couldn't actually provision new virtual machines. So you still had to have somebody, a sysop, come in, provision this machine, go in, install the software agent, and then let it run. So then we saw, and that was back in the late 2000s. Early 2010, we saw the rise of the second generation configuration management like Ansible and SaltStack, which could actually provision the virtual machine, install the agent, and run the scripts, which is fantastic. This is where we're starting to get into infrastructure as code. And if you're not familiar with that, it's taking all those scripts and defining how we want our infrastructure to be so that we can build that infrastructure. About that same time, we saw the rise of public cloud infrastructure. If you're not familiar with cloud infrastructure, although you probably are, it's hardware, but through automation and software, containerization, virtualization, we're able to distribute that, and then you can rent those resources, the computing power, networking, virtualization, you can rent that out to the public. So we kind of saw the rise of that. The unfortunate piece with cloud infrastructure was they were writing their own infrastructure as code. So on AWS, it was CloudFormation. On Azure, it was Azure Resource Manager. I forget what Google used. But they all had slightly different ones. But now we're at the point where we have this publicly rentable resources. We've got infrastructure as code. We're primed to begin to automate. And that's GitOps. GitOps was coined in 2017 by Alexis Richardson, who is, I just lost my laser pointer, there it is, the CEO of Weaveworks. And he envisioned this idea where we could manage operations, infrastructure, more automatically. So we could take some of what we've learned with DevOps and begin to apply to infrastructure. We could create he wanted to see the standard operating model too, where it was cloud agnostic. So instead of having to have an AWS person and having to have a Google Cloud person. Instead, we had this abstraction where we could write our configurations, we could write how we want our infrastructure to be, and something else would transpile it into the specifics for any given Google or any given cloud provider. So the actual definition of GitOps is it's simply a framework where we take the best ideas and the best practices from DevOps and apply it to our infrastructure. Now with DevOps, if you ask a room of 10 people, you're probably going to get 8 or 9 different definitions of DevOps, right? Same thing for GitOps. In fact, Alexis was asked in 2018 for a one-sentence definition. He focused in on the end product, and that is his dream was that you would have infrastructure that would continuously monitor itself. And it would say, what am I supposed to be versus what I am, where I'm at right now, and self-heal itself and fix itself and put itself back into the correct state. Now, another definition, this is from Agile Portugal in 2018. I forget the author, but he has GitOps in one slide, and you can see it's Git is the single source of truth for your infrastructure, that all changes that occur to the infrastructure, be that create, delete, edit, whatever, occurs in that single source of truth, and that every change is observable, verifiable, and importantly, replicable. So like anything that gets some legs underneath it, it gets some momentum. GitOps was broken away from WeWork specifically into its own working group with the Cloud Data Foundation, and they came up with a set of principles. Now I'm going to go through all of them, and then we're going to dig into each one to make sure we're all clear on what these mean. But it's that any system that is managed through GitOps is described declaratively, that wherever it is living, wherever that canonical source of truth is versioned, that as soon as a change is approved, it's automatically applied to the infrastructure. And then back to what Alexis envisioned, we have something running that says, where am I, where should I be, and then tries to heal itself or get itself back to where it should be. So because there's some terminology, again, I want to kind of dig into each of these. So that first one is that a system managed by GitOps must have its desired state described or expressed declaratively. And I do have an example of kind of that expression. So system, what do we mean by a system? Well, we're talking about everything that makes up the infrastructure. Think of it now more as infrastructure as a dependency of the application. What is everything that you need in order to run? I always like to show this diagram of WordPress hosting on AWS, and I have built one of these, actually more than one of these before. You can see this is a lot more than just a database and a web server, right? It is a whole bunch of stuff. It's virtual machines, it's containers, it's your networking, it's your NAT routers, it's the databases, the storage, your security roles, your security groups. It's all of the pieces. So when GitOps says a system, it is everything involved in getting that project or that application to run. The desired state then is the aggregation of all that declared data. All right, it's all those pieces together so that you can recreate the system such that it's indistinguishable behaviorally one from another. Now, it's important to remember or point out at this point that this does not apply to persistent data. So your database, your actual database storage, your file uploads, it's not about that. It's just about how the infrastructure should operate. That last piece then is the declarative description, and that describes the desired state of the system that you want, not how to implement it. There is a clear delineation here. So way back at the beginning with the physical hardware, it was often imperative scripts. It was, I want to install this, and I want to configure it this way, and then I want to install this. It's not what we do now with the declarative statements. Instead, we say, I want an Apache server, I want this version, I want to open this port, I want it to work this way. All right, the next one, and this one I found interesting as I dug into this. The term is GitOps. We saw a slide that says Git is the canonical source of truth, but the actual principle is it can be in any version control system. It just has to be immutable once the change is accepted, it has to be versioned, and it has to contain a complete history. Ideally, then, it should also have authentication, because we don't want just anybody to make changes, right? And it should have an audit log so that you can see what was changed, as well as some metadata about why it changed. So conversations around why it changed, who approved it, etc. So what does that kind of describe? See, I got you all sleepy. I'm going to keep poking you, keep you awake. What does that describe? Git, right? And especially with the configuration management software systems that we have, like GitHub, GitLab, Bitbucket, all of those, this perfectly describes it. So it's obviously had it in mind, but you don't have to use Git to do GitOps. Just pointing that out. All right, so the next one is that we have a software agent that automatically applies those changes. There's two models for doing this. There's either a push system where the configuration changes are approved, and then we push those configurations to that agent, and then it applies it. Or it can use a pull model where it's monitoring the repo, and as soon as it sees that change, pulls in those. The important piece here is, though, that we have a distinct firewall between what we want and any credentials to actually apply it. Our credentials aren't stored in the repository. We're only storing the idea of the infrastructure as we need it. All those credentials are actually stored where it's implemented. So we have that nice delineation. And then that last piece is that some software inside the infrastructure should be monitoring the system consistently, diffing it from what it should be with what it is, and then attempting to self-heal and self-repair. And if it can't, then alert and have human interaction or intervention. So a couple of quick diagrams or models of how GitOps, the GitOps workflow works, is we've got a developer. He pushes some code to a source code repository. It works through your pull request, your merge request, whatever Git workflow you're using. It's accepted. It triggers a pipeline, maybe Jenkins or something. It builds an artifact, builds that image application, which is possibly pushed out to an image repository. And then we might have the agent pull that image once it sees it, or we might push to it, which then deploys cloud resources. In addition, your infrastructure operations team might make some changes to configuration, again, pushing out or pulling, then deploying. Another similar example, another workflow, just to give you a different idea. Again, we've got the developer making changes, pushing out, building, and then we've got, in this case, we're pulling, or no, we're pushing this one. The other one was pulling. So this one pushes it out to Helm, which is a Weaveworks solution for that agent. Same thing here, we've got the operations team pushing changes, it pushes it out there, and then it's pulled in to our actual infrastructure, and those changes are made. So does the overall idea of GitOps make sense? That makes sense? So to boil it down, it's just taking infrastructure for the developers and making it a dependency of the application so you are in control, because you're the ones driving the stack, right? We need to get that control, that ability down to the devs so they can be faster. So how is it different from DevOps? Well, embarrassingly, for the longest time, I thought GitOps was just DevOps with Git, or it was a buzzword, right? It's not really, though. They're connected. GitOps is a branch of DevOps, a supporting branch, but you can do GitOps and not do DevOps. You can do DevOps and not do GitOps. DevOps is more focused on that human element, right? Collaboration, communication, getting the team together, getting them refocused with a similar goal, and then audit. And there are some tools, right? We're going to automate that software cycle. But GitOps is almost exclusively focused really on the tooling, right? We're using Git, we're doing builds, we're pushing, we're taking that infrastructure information and then rebuilding the infrastructure. So again, they're similar, they're connected, and GitOps is certainly a supportive piece of DevOps. So what are some of the advantages for the institution, your organization? Well, the big one is greater deployment frequency. So I noticed somebody earlier saw on my first slide about deploying on Fridays. Right? How many of you enjoy deploying on Fridays? Am I the only one? Okay, so if we're using GitOps, what is one of the first things in that very first principle that it stated? That the infrastructure that we build is indistinguishable behaviorally, right? So in GitOps, I know that if I build my application on the infrastructure and that what I just built is behaviorally identical to what I will deploy, I can deploy on Fridays because it can't break. I just tested it. So the organization gets greater deployment frequencies. Because we're tracking in Git, every commit in Git has that unique hash, right? And it's immutable. You can't change it once it's committed. So if my infrastructure has already been tested and committed, then I can roll back at any point to an older version of infrastructure, and I know it's going to work exactly like it used to. So we greatly reduce that downtime. It's less error-prone because we've taken a lot of the human element out of it, right? We now have codified those configuration files, that infrastructure. We put it in. We're also going to run it through workflows where we're going to have reviews and audits, and people are going to be viewing it, which also increases the operation across teams, right? You're not going to get the surprises because you're probably going to have an infrastructure person auditing and approving a change. You're going to have a developer approving it and auditing a change. And so, again, whoops, I hit the wrong button. Back out. There we go. So you're going to have a lot more greater communications between the teams and a lot less surprises. And you're going to have improved security and compliance. We've got that baseline configuration For all of our infrastructure, we're rebuilding from that same set of code, and it's every time it's built, it's the exact same, so security and compliance is much greater and much easier. Now, most of you are developers, so what are the benefits for you? What benefits do you get out of it? Well, you get to focus on what you do best, right? You get to focus on development. So now if you need a node stack, depending on how your organization implements GitOps, it could be as easy as saying, I need a type of node 14, add, commit, push, and now you have it, right? It takes all of that infrastructure and exposes it to you as a developer so you can focus on being faster. More specifically, it's using the same tools you're already familiar with, right? You probably already use Git. You're probably already using some type of Git workflow. You're just adding one more piece in. And you probably already use YAML files and JSON files, which is how most of the configuration is described. So you're already used with that, which, and I don't know why I put this at the bottom, but it also makes onboarding easier, right? So if you bring a new person in, well, they probably already know Git. All you have to do is teach them the specifics on how you've implemented your templates, and it's just part of their workflow now. It says infrastructure becomes a gated process. It's not gated so much as it's that collaboration, right? You're going to have reviews. It's going to go through a regular workflow. Everybody's going to be on board. The big ones for me was the same realization I had when I finally got Git, when it finally made sense to me. And that's that I had this freedom, I had this confidence that I could experiment safely without breaking anything. And I liken it to the Marvel meta universe, right? Multiverse. I can create a whole other universe of my code. And I can test, and I can play, and I can experiment. And most importantly, I can fail quickly and fail often, because that's when you iterate. If you can fail quickly and fail often, you can figure out how to do that next thing. But I can do it safely because I know if something else comes up, I can quickly switch branches. I don't have to worry about backing out of that code. I don't have to worry about losing that information and that work. I can just switch branches, do my changes, and if I make changes, I can merge those back out into my multiverse. You get the same power and freedom now with infrastructure. So if you want to experiment with a Python stack using Fast API for microservices, you can do that. If you want to start playing with decoupled and doing a node or like a Next.js, you can deploy that and begin to experiment and play. And you know that once you're done, if you merge that back in, it's going to work exactly the same as when it was in development. So again, you get this experimentation, this freedom to experiment, and these faster iterations. All right, so some disadvantages. Again, I don't like really saying disadvantage so much as just what does it not do? Well, first is you kind of have to be either cloud native or be using some technology for your infrastructure that can be automated, where you can describe its infrastructure in configuration files. You can certainly use parts of GitOps and not that piece, but you don't get the full benefit. Because your infrastructure now is in a repository, and that repository is the canonical source of truth, and you have a different repository for all your projects, you do get a lot of repositories, which can make auditing more complex. Still do it. We can get the Git logs. We can go into all those configuration files and see exactly what infrastructure we have. But with that proliferation, it just makes it a little bit more complex to get that back out. While we do have that nice delineation between our configuration of what we want for the infrastructure and the credentials for actually implementing it, it doesn't address directly any central secret management. So if you have API tokens or something else where you need to inject those into your application to be able to do that, GitOps itself does not address that. Same thing for input validation. So if you put in the wrong configuration information into your configuration files, GitOps by itself isn't going to take care of that. You're going to have to figure out as an organization, when do we do input validation? How are we going to do that input validation? I mentioned this one earlier. It does not address that persistent application data. So while you can create a node app, you could create another like PHP 5 or 8.2, you want to test that out. Your persistent data isn't part of GitOps. That's a piece you'll have to figure out whether or not you want to clone over that production data into that development environment or whether you want to test without it. And the last is Git's just not designed for programmatic updates. And what I mean by that is if you have some type of maybe scheduled pipeline or software agent that's attempting to update parts of the infrastructure and commit that back into that repository, what can happen is one can start through that PR process. and another one can start up. And by the time the first one has been committed, the second one is now behind. So you have to build in some type of system that's going to pull, or worse, you end up with merge conflicts where you have to have human intervention. So it's just not built for programmatic updates. All right, so that's GitOps. I actually forgot to start my timer, so I'm not sure how much time I have. But that's GitOps kind of in a nutshell. If this is of interest to you, I do have some resources up here. That first one is the working group I mentioned. The second one is kind of a community page to bring education and public knowledge about GitOps. GitLab, Bitbucket, or Atlassian, I should say, GitHub, they all have wonderful documents and articles about GitOps because they all want you to use their version control system managements to do your GitOps workflows. GitOps Tech has a ton of resources. The last one's actually really interesting because it's a workshop on GitOps. So for a few dollars worth of Amazon resources, you can actually work through building your own GitOps workflow and deploy infrastructure out at using AWS. Now, I will say that GitOps is complex, right? There's a lot of pieces to it and a lot of moving pieces. I like to liken it to this parody book cover that's managing your applications in Kubernetes, where it's step one, draw these two circles. Step two, have a complete drawing, right? There's a lot of stuff between step one and step two that goes on. So this is the one time I will plug the company that I work for, just once. If you're sitting here and you're saying, I like the idea of GitOps, I like the benefits you've described to me, but I don't have the talent on staff, I don't have the time, I don't have the resources. Platform.sh, the company I work for, is a platform as a service company that does GitOps. We provide you all the tools that you need to adopt a GitOps workflow without having to have a dedicated infrastructure team. And I like the quote that Larry Garfield said. You might recognize his name. He used to be in the Drupal community, and now he works for Typo. He described Platform as a GitOps done right as a service, essentially is what he said. That's all I'll say about my company. So if you have any questions, I'll entertain them. I am super easy to get a hold of. If you search my last name, you'll find me. Or this is my business card. I don't have business cards. I just have the QR code. So yeah, I'll take any questions that anybody has. I think the glasses was first.
Can you share these slides?
Oh yeah, absolutely. I will provide them to you.
So the whole video will be up on the WordCamp national site probably in a week or two-ish. But obviously, if you want slides, reach out to Paul.
Yeah, I can share them. That's not a problem. And then, yeah.
Yeah, who's the chief product officer there at Platform?
At Platform? I believe it's Fabian, and I forgot Fabian's last name. Fabian, if you're familiar with Symfony,
Yeah, exactly.
Fabian wrote Symfony.
Yeah, no, I just was looking at the site.
Oh yeah, yes. It begins with a P, and I can't. It's French.
I was honestly hoping you did.
Oh, okay.
I said it's Montclair, but
So the CPO is the gentleman that wrote Symfony, and a huge chunk of all the Symfony services and offerings. Yeah, he's our CPO. We have a lot of smart guys at the company, and way smarter than me. Any other questions? Yeah.
So you talked about, like, with the GitOps workflow, it may not affect persistent data. Do you have recommendations on how to deploy WordPress data, and how do you include that in your GitOps workflow? Because WordPress is like half comprised of like data that's in SQL and not code.
So I can tell you how we do it. And that is we do copy on write. So we do a read-only clone of the database and the files into any development environment that's brought up, whether that's development or staging or whichever. And then it doesn't actually change until you start to write to it, and then it'll do a copy on write. So then it'll copy it over. So that way it's separated. So whatever changes you make in development are going to be in production, but it's a lot faster that way. That's just one piece that we fixed. Again, your organization would have to figure out how you want to do that because it'll depend on your infrastructure that you're using. Yeah.
So like Terraform and Ansible are just like two tools to do GitOps?
Yeah.
GitOps is more the theory?
Yeah. GitOps is more the theory. Terraform with their HashiCorp declarative language, HDL is HDL, I forget now. That's that configuration language and that transpiler. So you use theirs to write your configuration, and then they handle transpiling it to the implementation on AWS or Google Cloud or wherever you want to go. But that's a key component. I forgot, Weaveworks has this similar thing. I forgot what theirs is named, though. Any other questions?
And then,
Oh, sorry, go ahead.
You like in your slides, you kept mentioning agents, but like Ansible's technically an agent, right?
Yes, so Ansible now, so all those Puppet, Chef, Ansible, SaltStack, there's a couple others, have all grown and now all have similar offerings. Yeah, so all of those that I mentioned now do some sort of GitOps capabilities. Yeah, the agent that's being used. It's software agent because there's so many options to use. It depends on how you want to configure it and use it. And it can also depend on which cloud provider you go with and how far into their specifics you want to go. Any other questions? Yeah. Oh, no. Oh! No, we know each other. It's fine.
You mentioned like defining that desired state,
Mm-hmm.
and that like it's monitoring and trying to like heal something out. So like I assume that's for if like there's a problem with infrastructure, you try to fix it. Does it do anything for like you getting more traffic and scale up, or like how do you handle that kind of stuff?
There certainly are things. That's not a part of GitOps, though. That would be an extra step. And so if there was one diagram that was writing back, so if an infrastructure is being changed, then that would be a part of saying, hey, we need to write that back to the repository to make sure that's recorded so that when we rebuild it, that piece is included. There's also other available options where you can have the particular cloud provider run the scaling for you. That's not really part of your desired state. So there's a couple of ways you can tackle it.
Okay, thank you.
Cool, thanks.
So Paul will be available right in the Happiness Lounge if anyone has any more questions. Maybe even want to ask a question in front of the group because for whatever reason. So make sure you hang out there for a little bit.
Okay, yeah, I'll go get my caricature.
Then get your character, yeah. Other than that, our next session will be in about 15 minutes. So enjoy some more snacks and more food.